Okay, today we are on chapter 4, day 6 notes. We're going to be talking about the maximum and minimum. So take a second to read this top part. So for quadratic equations, some problems will ask for the maximum or minimum value. So when we have a question like that, we are going to complete the square so we end up in vertex form. Other problems will ask for the input that gives the max or min value. So when that happens, you're going to find the x coordinate of the vertex. So we can use x equals the opposite of b over 2a. And then if our equation is not quadratic or quadratic-like, then we are going to use our graphing calculator to determine the max or min point. So for this first example, we are looking to find two numbers that add up to 20 such that the sum of their squares is as small as possible. So we're going to let x equal the first number and let y equal the second number. Okay, so first we are finding two numbers that add up to 20. Okay, and we were told that the first is x and the second is y. So x plus y equals 20. Okay, the next, it says that the sum of their squares is as small as possible. So the sum of their squares would just be x squared plus y squared. It's the sum of their squares. Okay, so now we're going to want to use substitution. So I am going to solve that first equation just for y. So now I have y is equal to 20 minus x, and I'm going to substitute that into the sum of their squares. So we will have x squared plus, now instead of y, I'm going to write 20 minus x squared. Okay, so then that is just going to be x squared plus x squared minus 40x plus 400, okay, which is then going to give me 2x squared minus 40x plus 400. I can factor out a 2. So I have 2 times x squared minus 20x plus 200. Okay, then I'm going to want to complete the square to get this into vertex form. Okay, so I'm just going to write that up here. Complete the square. Okay. Okay, so to complete the square, I'm just going to rewrite this now. I have 2 times x squared minus 20x, and then on the outside, I'm going to have plus 400. So I am always going to divide my b term in half and then square it. So I'm going to have 2 times x squared minus 10x plus 100, and then plus 400 minus 200. So I'm subtracting 200 because don't forget we have this 2 on the outside, so that 100 on the inside is actually 200. So whatever I add, I do have to make sure I subtract to keep it even. Okay, so now I can just rewrite this as 2x squared minus 10 squared, and then plus 200. Okay, so this is a parabola, and since my a is positive, I know I'm going to be opening up. So my parabola is going to be looking like this. So I do have a minimum point. Okay, so my minimum point, since this is in vertex form, my minimum point is going to be x when x is 10. Okay, so now I'm just going to substitute that back into this original problem of the two numbers that add up to 20 to find out my y coordinate. So then I have y is equal to 20 minus x, which was 10. So y is equal to 10. So we are trying to find the two numbers. Both numbers are actually 10. Okay, so for number 2, it says among all rectangles having a perimeter of 25 meters, find the dimensions of one with the largest area. Okay, so first, I have a rectangle. We're going to have x, we have y, and we know the perimeter is equaling 25 meters. Okay, now it's asking us to find the dimensions. So when it's asking us to find the dimensions, we're looking for the input that gives the max or min value. So that is where we're going to look for the x coordinate of the vertex. Okay. All right, so first we know that the perimeter is going to be equal to 2x plus 2y. Okay, and we know that the perimeter is equal to 25. So 25 is equal to 2x plus 2y. So now let's go ahead and solve for y. So I'd have 25 is, 25 minus 2x is equal to 2y. Then let's divide by 2. So now I have 25 minus 2x divided by 2 equals y. Okay? Now we're looking for the largest area. The area is equal to x times y. So now we can substitute. So we have x times, now instead of y, we're going to have 25 minus 2x divided by 2. Okay, if I distribute my x, I'm going to have 25 minus 2x squared divided by 2. Okay, if I just split that up, I will have, sorry, I'm missing my x right there, 25x minus 2x squared divided by 2. So if I split that up, I'm going to have 25x divided by 2 minus x squared. So let's rewrite that to have negative x squared plus 25x over 2. Okay, so that is what the area is equal to. Okay, you may notice that this parabola is opening down. Okay, and that does make sense since we are looking for the maximum value, since we want to have the largest area. Okay, so next, it tells us up above that when we are looking for the input that gives the maximum value, we're going to use the x-coordinate of the vertex by using x is equal to the opposite of b over 2a. Okay, so the opposite of b is going to be negative 25 over 2, and then 2 times a is going to be 2 times negative 1. So we have negative 25 halves divided by a negative 2. So let's just simplify that. I'm going to have negative 25 over 4 over a negative 4, which then, of course, both my negatives cancel out. So I have 25 fourths. Okay, so that is the x-coordinate of our vertex. Now we're just going to substitute that back in to find out the y-coordinate. So here I have y is equal to 25 minus 2 times 25 fourths all over 2. So y is equal to 25 minus 25 halves all over 2. So let's simplify that. So I have y is equal to 50 halves minus 25 halves divided by 2. Y is equal to 25 halves over 2. So last, y is equal to 25 over 4. So the dimensions of this rectangle is actually going to be 25 fourths meters by 25 fourths meters. Okay, so you may notice that the dimensions end up being a square. That's not by coincidence. If we have a rectangle and we know that the perimeter is going to be 20, I could have 5 by 5, 5, and 5, or I could have 2, 2, 8, and 8. Okay, well, of this first one that has all side lengths of 5, that would give me an area of 25, and the second one would give me an area of 16. So if we're looking for the maximum or the largest area, it is going to end up being a square. Okay, and number 3, we are looking for the largest possible area for a rectangle with a perimeter of 80. So if we are looking for the largest possible area, I'm going to be looking for that y-coordinate of the vertex. Okay, so I'm just going to sketch this out first. I have a rectangle with side x, side y. My perimeter is 80 centimeters. Okay, so I know that the perimeter is equal to 2x plus 2y. The perimeter is 80, so we can substitute that in. Now let's divide everything by 2. So we have 40 is equal to x plus y. Then just solve for y. So y is going to be equal to 40 minus x. Okay, now the area is equal to x times y. So it's going to be x times, substitute in, 40 minus x. Let's distribute. So we have 40x minus x squared. I'm just going to rewrite that So we have negative x squared. So we have negative x squared plus 40x. Okay, now we're going to complete the square. So to do that, I'm just going to first factor out that negative. We have negative x squared minus 40x. Now let's complete the square. So I'm going to have x squared minus 40x. If I divide that in half, I get negative 20. Square that, we get positive 400. Okay, now whatever I add or subtract to complete the square, I have to remember to do that on the outside of the parentheses. If I distribute that negative, I end up getting a negative 400, so I need to actually add 400. So let's simplify that. I'm going to have x minus 20 squared, and then plus 400 on the outside. Okay, so this is going to give me my vertex. My vertex is actually going to be 20, 400. So that is telling me that the maximum area is going to be 400 centimeters squared when x is equal to 20. So the maximum area is going to be 400 centimeters squared. And again, that's when x is equal to 20. Here's my x, here's my y. Okay, number 4. What is the largest possible area for a right triangle in which the sum of the lengths of the two shorter sides is 100 inches? So we are going to be looking for two equations to then write our answer in vertex form. Okay, so again, we are looking for the largest possible area. So I do want to find the y coordinate of the vertex. Okay, so this time we have a right triangle. So we will have x and y, and I know to pick those two sides because it says that the sum of the lengths of the two shorter sides is 100, and of course the side across from the right angle, the hypotenuse, is the longest side. So I know that x plus y is going to equal 100. So let's solve for y. So y is just equal to 100 minus x. Okay, and we're looking for the largest possible area. So the area of a triangle is 1/2 base times height. So in this case, we have 1/2 x times y. So if I substitute y in, I'm going to have 1/2 x times 100 minus x. So that is going to give me 50x minus 1/2 x squared. Let's rewrite. I have negative 1/2 x squared plus 50x. Okay, now I do want to complete the square. So in order to do that, I'm just going to first factor out a negative 1/2. So if I do that, I have negative 1/2, then I'm going to have x squared minus 100x. Okay, now let's go ahead and complete the square. So negative 1/2, and I have x squared minus 100x. So if I divide negative 100 by 2, I get negative 50, and if I square that, I get positive 2,500. Okay, now I need to make sure that I cancel that out by doing the same thing to the outside. So if I distribute that negative 1/2, I would end up with negative 1,250. So I'm just going to add that on the outside so that it cancels out. Okay, so now I have negative 1/2. I'm going to have x minus 50 squared plus 1,250. Okay, so now that is in vertex form. So the vertex is equal to 50, 1,250. So here we do have our parabola. It's opening down, so we were able to get that maximum point. So when x is equal to 50, the largest possible area is going to be 1,250 inches squared. So number 5, which point on the curve y equals the square root of x minus 2 plus 1 is closest to the point 4, 1? What is the minimum distance? So this is going to be a two-part question. So we are looking for which point is closest to the point 4, 1, and then what is the minimum distance? Okay, so first I'm just going to kind of sketch what this looks like. It's just a sketch, it's not going to be extremely accurate. But 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to sketch y equals the square root of x minus 2 plus 1. So I have my first point at 2, positive 1. Then I'm going to go up 1 over 1, up 2 over 2 from here. So it's going to look something, again, this is just a sketch. It's going to look something like this. Okay, and then I have my point 4, 1. So I'm going to be looking for what is the closest point, so probably something right around here to that point 4, 1. Okay, so every point on this curve is going to have the coordinates x and then the square root of x minus 2 plus 1. Okay, so we are going to be using the distance formula. So the distance formula, so distance is going to be equal to, we have the square root. So let's take that first point. So I'm going to have 4 minus x squared plus 1 minus the square root of x minus 2 minus 1 squared. So if I simplify that a little bit, I'm going to end up with the square root of 16 minus 8x plus x squared plus x minus 2. Let's keep going. So the distance is equal to the square root of x squared minus 7x plus 14. Okay, so now I'm actually going to square both sides. So I have the distance squared is equal to x squared minus 7x plus 14. So just like we've done with all the other problems, let's go ahead and complete the square. But don't forget that this is distance squared. Okay, that's going to be important at the end of this problem. So we have distance squared is equal to x squared. Let's rewrite that. We've got x squared minus 7x. So if I divide negative 7 in half, I'm going to get negative 7 over 2. And then I square that. So I'm going to get 49 over 4. So plus 49 over 4. Okay, then on the outside I have plus 14 minus 49 fourths. So my distance squared, not sure why it keeps making a little box. Distance squared is equal to x minus 7 halves squared plus 7 over 4. Okay, so I know that the parabola is going to be opening up. Okay, and the x coordinate is going to be equal to 7 over 2, but we want to find out what the y coordinate is so we can find that minimum value. Okay, so we know that y is equal to the square root of x, which is 7 over 2, minus 2, plus 1. So I'm going to end up with the square root of 3 halves plus 1. So that will get us 2 plus the square root of 6 over 2, or 1 plus the square root of 6 over 2. Okay, so the distance, we're looking for the minimum distance. That minimum distance is going to be the square root of 7 over 2. And then the point that happens at to have that minimum distance is going to be at 7 halves as an x value, which we found from the vertex. And then that y coordinate was 2 plus the square root of 6 over 2. Or you could write it as 1 plus the square root of 6 over 2. The distance being the square root of 7 over 2 does come from right here, that y coordinate of the vertex, but keep in mind that that was distance squared. So if the distance squared equals 7 over 4 as being the y coordinate of the vertex, we do need to take the square root. So then we know that the distance is going to just be the square root of 7 over 2, which is where we got that answer.